Hello, my name is Varun Vijay, and today we'll be talking about computing systems summary. So, the internet is totally changing how people interact and connect, but how does it work? How do computers all across the world actually communicate with each other? When opening a browser, the first step is to type in the web address, or URL, which stands for Uniform Resource Locator of the website. In the moments right after the URL is searched, the computer starts talking to another computer called a server. In milliseconds, the computer asks the server for a website. That server starts to talk back to the computer in a language called HTTP. HTTP stands for Hypertext Transfer Protocol. It can be thought of as a language that one computer uses to ask another computer for a document, and it's very straightforward. If you ever intercept the conversation between your computer, which is shown by these lightning strikes, you get something mainly made up of called GET requests. Those are really very simply the word GET and the name of the document that you're requesting. So if you're trying to access the website, all you're really doing is sending GET requests to the page's server that says GET, and that tells the website server that you want all the HTML code for the page. So let's just say you want to search something simple. So let's do about Google. So once we search about Google, we get a couple of websites, and we'll choose the simplest one, which is Wikipedia. All Wikipedia is just a simple document which is consisted of various HTML features. We have bold text right here. We have blue text, which can allow us to go from page to page, and we also have a picture, all of which are parts of HTML text. HTML stands for Hypertext Markup Language, and you could think of that as a language used to tell a web browser to how to make a page look, as I stated before. The text of a web page is included directly in the HTML, but other parts such as images or videos are separate files with their own URLs that they need to be requested as well. The browser sends separate HTTP requests for each of these and displays them as they arrive. If a website has a lot of different images, each of them causes a separate HTTP request and the page loads slower. So, now that the internet is completely open, all of its connections are shared and information is sent in plain text. Because the internet is wide open, almost as if an open door, it's easy for hackers to snoop in on any personal information that you send over the internet. But safe websites prevent this by asking your web browsers to communicate on a secure channel using something called Secure Sockets Layer and its successor, Transport Layer Security. You can think of SSL and TLS as a layer of security wrapped around your communications to protect them from snooping or tampering around, meaning that your hackers are behind bars. The part of the internet we see day to day, to summarize, is that HTTP and DNS manage both the sending as well as the receiving of HTML, media files, or anything else on the web. What makes it possible is that under the hood, TCP, ICP, IP, and router networks break down and transport information into these packages. When these packages are opened, their outcomes are small packets. These packets are made up of binary sequences of ones and zeros that are physically sent through electric wires, fiber optic cables, and wireless networks. These packets do not need to follow a fixed path. In fact, your path may change. Many kinds of digital information can be sent with IP packets, but there are some limits. You can send small packets or information. However, if you're sending a very large image that you want to send to a friend or upload to a website, that image may be made up of tens and millions of bits of ones and zeros that would be too many to send along in one packet. However, since it's data on a computer, the computer sending the image can quickly break it into hundreds or even thousands of smaller parts called packets. Each packet has an internet address of where it came from and where it's going. Special computers on the internet called routers act like traffic managers to keep the packets moving through the network smoothly. If one route is congested, individual packets may travel different routes through the internet and they may arrive at a destination at slightly different times or even out of order. As part of the internet protocol, every router keeps track of multiple paths for sending packets and it chooses the cheapest available path for each piece of data based on the destination IP address for the packet. Often, the best route for the data to travel isn't the most direct. Having options for paths make the network fault tolerant, meaning the network can keep sending packets even if something goes wrong. This is a basis for a key principle of internet reliability. Now, what if you want to request some data and not everything is delivered? How can you be 100% sure that all data will be delivered and the website will relay its information? This is where TCP, otherwise known as Transmission Control Protocol, comes into play. TCP manages the sending and receiving of all your data as packets. When broken up packets arrive, TCP does a full inventory and sends back acknowledgments of each package received. If all the packets are there, TCP signs for your delivery and the process is complete. If TCP finds some packets that are missing, it won't sign, otherwise the website will not function properly. For each missing or incomplete packet, the website will resend them. Once TCP verifies the delivery of many packets, the website will successfully function. In fact, because of these principles of fault tolerance and redundancy, the more routers are added, the more reliable the internet becomes. What's also great is that the growth and scale of the internet can be exponentially improved without interrupting service for anybody using it. The internet is made of hundreds and thousands of networks and billions of computers and devices are connected physically. These different systems make up the internet connected to each other, communicate with each other, and work together because agreed upon standards for how data is set around the internet. When there is any type of network consisting of several routers, this is known as dynamic routing, which is the best way of routing since it's scalable and can automatically determine better routes if there's a change in the topology. Although there is more to the configuration of dynamic routing protocols, there are simpler ways to configure in a large network. Thanks for listening and hope you have a great day.